And we are back as we continue our series, Conversations on COVID-19. We're talking about institutions helping out the healthcare system. We just heard from Bloomsburg University. Now we're going to head west to Bucknell University to talk with Nate Siegel, Brandon Vogel, Rachel Michaels, Xander Karpovich. I'm sorry, I just absolutely butchered that, Xander. And we're going to talk to them about the work they have done for Geisinger with PPE. So I'll just throw the question out there. Whoever wants to field it can. Where did the idea come from for your work?
I guess I'll start. The idea came from basically some of us were individually approached by friends and colleagues that work at Geisinger to help them deal with a perceived shortfall in some of the personal protective equipment that they use. It started really with face shields and the N95 respirators. So that sort of happened, a bunch of us getting contacted in parallel. And then we also were contacted by Penn State to collaborate on their effort with Hershey. And then over time, we kind of got everybody connected. And finally, about a week and a half, 2 weeks ago, another group that's sort of a Danville community group, loosely affiliated with Geisinger, started getting us more involved with distributing things locally to not just Geisinger and Evangelical, but other hospitals and clinicians who didn't have enough PPE.
So one thing I heard there almost immediately is that you really worked very quickly on this.
Yeah, it was very rapid response. And some of the things, I mean, Brandon can talk about what he did for the intubation tents. I mean, that was done in a matter of days. I don't think he slept.
Yeah, my wife had actually reached out to some friends of ours, and the husband is an ER doctor at Evan, and she said, "Hey, do you need anything?" And he said, "Well, actually, we need intubation tents." And so I quickly went into action along with Eric Kennedy.
All right, so let's talk about the intubation tents. How did you come up with the design, and what was some of the work involved in it, the pluses, minuses, some of the hardships you went through to put them together?
Yeah, well, so actually Eric Kennedy, who's a biomedical engineering faculty member, he and I went to Evan to meet with this doctor, James Connolly. And James kind of laid out the problems or the design constraints. They have various bed sizes, widths, lengths. They have mobile beds, whether it's on an ambulance or not. They wanted to be able to get behind the patient and do the intubation. It turns out actually they don't do it by hand. They do it by hand, but they actually use a camera that they're watching through, which I was surprised. I always just thought, you see ER or something like that. and ER is an old reference, yes. And so they also wanted to be able to do things like compressions from the side. So if you look at the way some other hospitals have designed theirs, they maybe have a plexiglass box that it houses. And so the idea is the patient is laying down, the box or whatever it is, sits around the patient, and as they insert the intubation tube, what can happen is bodily fluid can kind of come out of the patient's mouth or from the throat, and then we're obviously worried about this mist. And so the way some of the boxes work it's a physical box. The way these tents or others work, which is like mine, is a frame, and you take a sheet, and the sheet goes over the frame and kind of surrounds the patient. And so they wanted the patient to feel more comfortable in these tents, and so they wanted more of an overhang or a canopy. And so this was basically a set of design constraints for me. So then I went out and I started building prototypes. I went through 5 or 6 different ones. If you see some of the other ones that have been built, you have maybe a 13-inch window where the doctors can get their hands and manipulate things. And so I knew we wanted at least 24 to 28 inches. And that becomes a real interesting design problem, because you can't have vertical members stabilizing the frame due to the fact that there's a bed there. And so you need to figure out how to kind of cantilever this situation. And so I created a number of prototypes, drew some things out, and then worked back and forth with the doctor. And so they tried an early prototype, but we decided it was too wide because it wasn't going to work for the ambulances. So I went back and made some adjustments and was able to find something that worked. So then over the course of a day and a half, I made 15 of them, delivered them, and these were able to, it was a significant amount of work. And these were actually capable of being broken down, so they weren't completely glued. And then they came back and said these are great for the ambulances and other EMS workers, fire departments and things. But we'd actually like some glued as well, fully glued. And so then I went back and I made another 12. So I made a total of actually of 28 because they have another prototype there too.
Now, did you at any point have to work with like a hospital bed or a gurney with a person on it, or do you just designed it right from on a computer?
I designed it pencil and paper. I figured that was faster. Yeah, and so if on my Twitter, I actually kind of walked through some of the design because I thought people might be interested, and so I posted a number of pictures of the images of some of my sketches and things, and you can see me doing some geometry calculations and Pythagorean theorem and things like that on there. And so just to try and get the angles right. Right. And so, but it's interesting, I teach design to chemical engineers. And so we have them interact with clients and go through this design process. And for me to go through it, actually at the same time they're doing it for a different application, it was really rewarding.
So it was quite a challenge for you, though, not only because of you had to come up with the design, but you did it quickly.
Yeah, they were really concerned when James had talked to me that within the next 7 to 10 days they were worried they were going to get a flood of patients. So I knew there was a quick timeline, and so I was staying up till 1, 2 in the morning, cutting, doing lots of designs, buying the parts myself initially. I ended up getting Home Depot to donate about 2/3 of the fittings and piping, and then Mifflinburg Lumber came through and they donated some more for the second set. So having the community partners and working together was really rewarding.
Okay, so let's shift now to the face masks. Whoever can talk about them. What was involved in them, the design of them, and what were some of the problems you ran into in making those face masks, the N95 face masks that we're all familiar with now?
So the N95 is okay. So you want to do face masks? There's face shields and there's N95 respirators.
Face shields, yes. The
shields are these guys, right? Okay. Yep. So this design, you can see, has a sort of a 3D printed headband that would basically go on like this. And this is a design that first started in Czechoslovakia and through a 3D printing company called Prusa. And we've since modified it to basically improve a few elements of it. We got some clear material donated from Construction Specialties, and they typically support a lot of our senior design projects. So they're kind of a long-term partner for us. So they gave us enough plastic to build 40,000 of them. So I don't know how we're going to do that, but so we've got what we say is a pretty finished design. There's a community group in Danville that's already been printing these headbands and supplying face shields, and now we're working with them to sort of supersize our effort. And Xander took one of the designs, this one, and adapted it for use in his local community. So he could probably tell you more about what he's doing with that.
Yeah, Xander, why did you feel that you had to adapt it for your local community?
So the idea was I have a mom who works for the local school district. I saw her working on making like cloth masks to cover patients' faces. And so after having class with Professor Siegel and seeing him kind of show off the face shield a little bit, I decided to talk to her about that and see if that'd be something that she'd want to get into. And so she took it to the school district, and we've been in communication with the St. Luke's in our town to kind of, we're still a little bit behind where everybody else is, but we're trying to work on a design that can fit the small 3D printers that we have here and also be able to produce enough for if this thing gets worse here.
Okay, so was yours more school-based that you were doing? You were doing it for a school or a hospital or both, or?
A combination of the two. So it was originally, it's for the hospital through the school, if that makes any sense.
Okay, yeah, and how you made several of them already for the hospital there?
Yeah, mostly just prototypes at this point. They pointed out some design flaws, like I know we talked about the gap at the top of the band before. They also have a special type of face shield material they want to use, so we've just been kind of talking about and like bouncing back and forth how to tweak this and make it work for them.
Okay, so the group also made some N95 masks, from what I understand. Who can talk about the design for those and any problems, issues that arose in making those quickly?
That'd be Eric and Rachel.
Uh-oh,
Yeah.
Rachel's here.
Although I think all of us could probably talk about it to some extent. It's
okay.
This is a pretty widespread effort. It involves it actually probably originated with Nate and some of his connections at Penn State, but it's a nationwide effort. You'll see a ton of people investigating different design options for N95 masks because we anticipate, or they already are, in short supply in many places. So there was an existing design that was out there that could be manufactured through the use of a 3D printer. And so we originally started, there was a group, and I apologize, I'm joining somewhat late, so you may have already talked about them, but there's a group of physicians that have kind of formed a GoFundMe and a community-based group over in Danville. And so we started talking with them and taking a look at that existing design, which was deemed it's termed the Montana mask. It came out of Montana. And we started to print and look at that. And we looked at that particular design and realized that it had certain features and things that we wanted to change. And so at the point where we had 3D printed this somewhat rigid mask that could be reused with a replaceable filter insert, we realized, like, for example, the original mask, it needed to have a gasket for its interface around the face, or it might not fit appropriately. And so that's actually when I reached out and got Rachel involved. Rachel is a senior BME who design project, her senior capstone project, involved a lot of silicone molding and creating the mold design. And at the time, we thought we needed to create some sort of gasket that we could put around the outside of the mask and then make several other design features and design changes. And so we've produced a prototype of this. I can let Rachel speak to her efforts in a second, but we produced a prototype of this, and we kind of have a, for lack of a better word, a complete design, and we have all the features incorporated together, and you can put the mask on. We have straps and things. We've done some testing with it. The issue that we have is that this is a rigid material, and so it's being that it's not compliant, we do have issues with it fitting and sealing on different users' faces. And so actually just even still today, Rachel, Brandon, Nate, and myself were all on a phone call with one of our contacts within Geisinger, and we're working on a alternative design that's going to turn this into a silicone molded face shield or face mask that uses some of the same features as this, but becomes a lot more compliant and potentially integrates and fits with the face a lot better.
Rachel, apparently you became somewhat of an expert at working that 3D printer, specifically in the design of the face mask, and from what other products as well. Talk about that.
Yeah, so my senior design project, I actually work really closely with a lot of the doctors at Geisinger and a lot of the doctors that we're working with right now in the N95 project. And my senior design project was to create this medical simulation, and it was really important to have this anatomical accuracy, especially with an aorta. And we wanted to build a fluid flow model, and it was a really, really big part of our project. So then I ended up creating this mold for a silicone aorta. So I had to create lots of different sweeps and lofts and all of these things to make a mold that it could be assembled in one piece and then kind of came apart after the silicone cured, and could create one singular piece, which was really challenging, but it gave me a lot of experience in making molds and figuring out how pieces have to work together, and especially when the environment is changing, especially with the silicone. So Dr. K texted me a couple weeks ago asking if I could help with some modeling for the gasket, because again, we really need to improve the seal around the face, and also improve comfort too, because the doctors have to wear these for long periods of time. And a lot of the comments that I've seen have been that doctors are having sores and developing sores from, or even like tension headaches from wearing these all day. So it was really important to improve the comfort and also the seal, obviously, for the mask. So I started off with the SolidWorks file, and I was trying to work around the previous design, and then I ended up actually just kind of tracing over it a little bit with the SolidWorks, and then kind of reverse engineering it to make it so that we could change it after that. And once we made the model ourselves in SolidWorks, we've been doing a lot of changes. We changed the filter window. It used to be a little square, and now it's a much larger circle. So that'll improve the amount of air that that doctors can actually breathe in, and it helps them a lot. So we ended up making a lot of changes, especially to the filter attachment. And then, like Dr. K said, we kind of reached the limits of our capabilities with the rigid mask. So now we're trying to work on a silicone mask, especially with compliance, because again, that's really important, and you want it to fit a lot of users, and you really need it to be comfortable too for the doctors.
So what I understand, you're a biomedical engineer. What kind of experience has this been for you as a student, number one? And number two, what's it like working on a project like this from your home instead of being on campus?
So, just to kind of start off, I decided to start with biomedical engineering because I really wanted to make things that could help the medical field. So that would be physicians and doctors and anyone in any healthcare workers. And I think this experience has really cemented that for me. I think it's really something that I've enjoyed doing. I wish it could be under better circumstances that I get to do all of this design work, but I really wanted to just make something that could help people. And even if it helps one doctor, that's really important. So I think that it's not under the best circumstances. Again, it's sad that it could be a life or death situation, but the fact that I get to help and work so closely with professors and other doctors too it's really cool. Again, you got to look for the silver lining, I guess.
And working from home?
It's a bit difficult, especially since I'm working on the designing and some of the materials. I am familiar with some silicones, but then when we've been trying to change the thickness and a bunch of other properties of it, so it's kind of, you have to think about what you want to do and then design based off that, and then send the 3D file to my professors. They'll print it out, test it, try it, and then they'll give me feedback. So it's a bit frustrating because I wish I could be there doing the design work too, or the 3D printing and the physical aspects, but I still get to see it and be really involved. So it's kind of just making the best of a bad situation.
Xander, what about you? What's it like? What's this experience been like for you as a student, and how has it been for you working from home?
So I guess as a student, it's kind of a lot of the things that we have been doing already. So primarily SolidWorks at this point, and 3D printing and all that stuff. In the mechanical engineering department, we do plenty of that. And as far as working from home goes, it's not too much different for me, mostly because I'm working with things I'm familiar with, like SolidWorks, which I have on my personal computer. I can just kind of pull it up and work, and then close it the same way I would or on campus.
So I take it SolidWorks is a computer program.
Yeah, 3D modeling.
Okay. All right. Talk about, I guess, either Brandon or Eric or Nate, talk about some of the partnerships that formed during these projects.
I guess I can speak to that. So there've been several. I guess the one that we're most active with right now is a group that includes elements of Bucknell. So Brandon, Eric, and I are both on that call, and Geisinger. So we have Alpin Patel and Sarah Flora, who both work in the radiology department. And then we have some folks who are Geisinger doctors, but are actually participating in this group as members of the Danville community. So primarily Sandy Green is heading that effort. And so his group is actually fairly extensive, and there was a couple press releases on them a few weeks ago. I think Karen Korzik was another doctor who is affiliated with that group, and they were sewing masks for people in her basement. And so they've since expanded to do face shields. There are people on this call that are through, NCIU, which is affiliated with, or CSIU? CSIU, right?
CSIU.
They're affiliated with the schools, so they operate a lot of 3D printers. So we've got this sort of core group, and we're focusing on face shields and N95s, and that's consuming a lot of our effort. We also have other groups at Geisinger and Bucknell who are doing things like the mechanical ventilator. So that apparently we have some designs for that look good. We're just waiting now to see if they're actually going to be needed. Outside of that, some other collaborations include what's called the MASC, M-A-S-C initiative out of Penn State. So they have a fairly large effort, primarily with Hershey Medical, to do essentially what we're doing here. So there's been a lot of cross communication on the design front, for example, and we've helped them develop things. We've used some of their designs. So there's been a lot of crosstalk. And then finally, we have the Evangelical Partnership, which has been sort of, we've been in touch with clinicians and also with their environmental safety folks. So Brandon's talking directly to the clinicians. I talk to the environmental safety people about the face shields. And so there's that connection as well.
Okay, so we are running out of time, which makes me sad because we're not going to get a chance to talk about our feelings. But if one of you, Brandon or Eric, could talk about really quickly about where do you go from here? Because I imagine you guys aren't going to be able to mass produce these items that you're making, although you have 40,000 face shields apparently. So why don't you guys talk about real quickly where you go from here?
Yeah, so I can jump in a little bit. This is actually something we've been thinking about. I've been trying to work with some local silicone manufacturers, local to Pennsylvania, and talking with them about fine-tuning the silicone mix for the mask, because the mechanical properties are important and things like that. And then trying to establish, well, how might we distribute this? So if there's talk about maybe forming a nonprofit or something like that, where we can get more donations and funding, and then make these designs freely available. But then what you have is you have the issues of obtaining material. And so if we can figure out ways to find a supplier who can supply material, then that allows us to basically distribute the fabrication of these masks. And for the face shields and things, students are able, or Nate or Eric, they can program a laser cutter, and the laser cutter can mass produce these things pretty quickly. And so which is amazing. I mean, it's amazing that we have the capabilities at Bucknell, and so we're really in a good environment.
Okay, Nate Siegel, Brandon Vogel, Eric Kennedy, Rachel Michaels, Xander Karpowitz, hopefully I got that right, from Bucknell University. Thank you very much for your time today. Thank you very much for your efforts, and I'm sure healthcare workers will thank you from Geisinger. That's going to do it for our program, this continuing series of In Your Neighborhood called Conversations on COVID-19. I'm your host, Chris O'Rourke. We'll see you next time, and stay safe.